Use mathematical induction to show that n is less than 2 to the n for all natural numbers n. We should have an intuition about this already. Intuitively, we know that this is x is less than 2 to the x because y equals x is a linear function and y equals 2 to the x is an exponential function. Exponential function always trump the linear function. But we will use mathematical induction to show this. The statement P sub n is n less than 2 to the n for all natural number n. To show this using mathematical induction, we will need to show the base case and the induction case. The base case is the case when k equals 1. When k equals 1, P of 1 is the statement 1 less than 2 to the 1. It is true because 1 is less than 2. For the induction case, we assume that the statement is true for k's, but P of k is the statement k less than 2 to the k. This is the case when n equals k. We then consider the case P of k plus 1. But what is the case P of k plus 1? It is k plus 1 on the left hand side, and we need to show, this is not true yet, we need to show that this is less than 2 to the k plus 1. To show this inequality, we first start with what we assume. We assume that k is less than 2 to the k, which is true. We then add 1 to both sides of this inequality because adding 1 doesn't change the inequality. The inequality less than is still less than when we add 1 to both sides of the equation. But we can do better than this. K plus 1 is less than 2 to the k plus 2 because if we add 2 to the right hand side, then the right hand side is still more than the left hand side where we increase the right hand side by 1. Again, the inequality still holds. But this is k plus 1 less than 2 to the k plus 1. Using what we assume about the case n equals k, we show that it is true for the case n equals k plus 1. So by the principle of mathematical induction, the statement 2 to the n is greater than n is true for all natural number n.